I wanted this control panel to have illuminated buttons that mimic some of the functions in Mach 3. I thought it might look pretty cool, especially if the e-stop reset button would flash. So this video is to show you the idea and what I had to learn to make it happen. So let's get started. So the bridge between the software and the hardware is obviously the parallel port breakout board. So when you see an LED turning on or flashing on your Mach 3 screen, so you ask yourself how to make a real LED to illuminate outside the program. And the answer is very simple, the same way you activate devices, through outputs on the port. On my control panel, the buttons I want illuminated are cycle start, hit hold, feed stop, hit stop reset, jog on, jog off, and the feed rate override reset. Starting with the cycle start, I want that LED to illuminate when the G-code is running. Then if I want to hold the feed, I want the LED to flash until either we resume or we stop the feed. Every time the feed stops, either by holding it or stopping it, I want the feed stop LED to illuminate for 2 seconds and then turned off. When there's a feed rate override condition, I want the feed rate override reset LED to flash until reset. On the jog on and off LED, I want it illuminated when jog is on and flashing when jog is off. Finally, the e-stop reset button will flash when active, but the flashing part will be done with hardware outside the program for reasons that I will explain a little bit later. Okay, let's open Mach 3 Mil. Now on the program, click on Operator, Brain Editor, and enter a name for your brain. I'm going to name mine Blinking Buttons. Notice that we have only 3 commands, the add, the remove, and the terminate lobe, the upside down T symbol. So let's start with the first instruction, since we want the LED to turn on when the G-code is running. So click on LEDs, now go to the signal window, scroll down to number 804, run command. As you can see, we have our first block with the run instruction on it. Now to terminate this instruction, if we go to terminate it, a window will pop out. The warning indicates that we have to add something else to the action. Click OK. Select again. Now click on the add sign again. Now see the window. We just want to pass the signal through. So it's a no operation, which is already selected. Click OK. Select it. Now we click on the terminator symbol. So click on the outputs. Now come down to the scroll window and look for output number 2. Click OK. And now we have created our first instruction, which is turn the green LED on while the machine is running a G-code and make the output number 2 go high. We're going to do the second button light now, the feed hold command. For this one, same thing. We want to turn an LED on, click on add LEDs, down to the list to 111, partial line holding, select it, click OK. Now on this signal, I wanted the LED to be blinking while activated, so we had to add a timer to do the flashing. Let's click on it, add, click on timer. We want to unselect a cumulative and single shot. On B, pulse time, I entered 0.33 seconds, and on delay till repeat the same 0.33 seconds. Now we can see our timing module block and click on the terminator. We want the result or action to be a high output, so click output, scroll to output number 3 and click OK. On feed stop, I want the light to turn on when active, only for 2 seconds. So again, go to add, but this time click on Mach variables and select the machine condition, stop, and click OK. Select it, click on timer and check a cumulative, enter 2 seconds on pulse time, leave single shot checked, select the module, terminator, outputs, output number 4, OK. Now we have the stop LED command. Our next signal is the jog on or off command. It's a little different since we want the steady light when on and the blinking light when off. Click add, go to LEDs, scroll down to 83, jog on signal. So now the signal is on and we wanted to make it flash when it's off. Select it, click add, select the invert radio button, but we wanted to make it blink. So select it, add, click on timer, and check a cumulative and single shot. Enter 0.33 on pulse time and delay till repeat as well. Now we have the blinking part done. So without selecting anything, click add, use LED number, enter 83, just to make it look different. So this LED signal when it's on, we will want it on. So select it, add, no operation. Now we can select both of them, click on the add button. So either one of these signals is steady on or flashing, we will pass through the signal to an output. So select the OR box, click Add, Terminate, scroll and select Output 5. Okay, for the Feed Override Reset LED, I want it to be flashing if active. Go to Add, LEDs, scroll down to number 17, Feed Override On, select the box, Add, Timer, uncheck Accumulative and Single Shot, enter 0.33 on pulse time and 0.33 on delay till repeat. Now it will blink when on. Select the box, Terminator, to outputs, select number 6. Now for the E-Stop Reset LED, we have two different input signals, the virtual LED itself, but also the E-Stop button that is hardwired to the machine. So we're dealing with two inputs and two totally different behaviors. And this was a situation that did not allow me to do this without the addition of external hardware to accomplish the desired result. Let me first write the brain part of it. Click on the Add, go to Inputs, select E-Stop, click OK. This is our E-Stop signal coming from the real button. Select it, Add, No Operation, click OK, select again, Add, Invert Signal, select again, Terminate, output number 7. That's all we need. With the E button pressed, we have a high signal. We flipped it, now it's low. Immediately Mach 3 shuts down all output signals down. All LEDs turn off. The screen reset LED starts to flash when an external stop is requested, either by the E-Stop switch or a limit switch. So if you try to reset it, it won't do it unless the E-Stop switch is restored. Once it's restored, the brain turns it on again, but the screen button will flash until activation is performed by clicking on it. Now we have to resolve the turn on the real LED and the blinking action on our next part. Here's the brain that we just created. To activate it on the program, go to Operator, Brain Control. Clicking on View Brain will bring up the window as it is here. Now let's observe this brain in action. First, you can see that a couple of instructions here are green. That would be jog on and stop. When the outputs are green, it means it's high or about 5 volts at the port. The red outputs are low or 0 volts. The system is in a normal condition, so in this case, the jog button is illuminated and the E-Stop output has 5 volts. Now if we click on the cycle start, output number 2 becomes high and turns the LED on. When I click on hold, output number 4 turns on for 2 seconds and then turns off. That is the feed stop LED. At the same time, feed hold becomes high with the flashing action due to the 0.33 second timer flashing the feed hold LED. If I resume the feed, it will stop flashing and the output number 2 becomes high again. If I click on the stop button, output number 2 becomes low, output number 4 becomes high for 2 seconds and then it goes low. If I click on the jog button, the first line of the instruction becomes high, making the timer flash the LED. If I click on it again, the second line becomes high and steady on. The last button or instruction is the feed override LED. Clicking on either override button will make it high, activating the timer and making it flash. Clicking on the reset button will become low again. Finally, if I click on the reset, the brain is not taken in count, but the machine goes into an emergency condition where Mach 3 shuts all outputs off, then the external inverter and the timer take over, making the E-Stop LED flash approximately every 0.33 seconds. As you can see, clicking on the virtual button does not affect the brain at all. Now to see the brain part in action, let me show you the actual panel when I press the E-Stop on. Watch output number 7 going from high to low. Clearly, it will not reset unless you restore the button. The thing to be aware of here is the flashing external LED along with the virtual LED. They appear to be in synchrony, but actually they are independent from each other. I will demonstrate the actual control panel at the end, so please bear with me for the next part: designing, building, and integrating the hardware. I designed and built this PC board to make the LED blink. It uses a transistor to turn a 555 timer on and off. The interval in which the light will blink depends on 2 resistors and a capacitor. The reason we had to make this circuit independent from Mach 3 is because once Mach 3 enters into an emergency stop condition, the software will shut all the outputs to the CNC controller off. Therefore, it won't be any signal available to turn the button LED on. You don't have to have a PC board to wire these components, but it will make it easier. You can also use a perforated board and solder all the components to it. If you want, you can pause the video and use the schematic as a reference to build the circuit. I'm using an illuminated arcade button with a 12-volt LED, but we need the LED to work with 5 volts. You can disassemble the switch and change the resistor with the correct one, usually 330 ohms, 1/4 watt resistor on a 5-volt circuit. Well, to begin with, output number 7 is high all the time on a normal condition. So output number 7 is feeding about 3 to 5 volts to the transistor gate, making the timer pin number 8 or VCC go to ground, so the timer is off. Whenever there's an stop condition, the transistor gate will go low, making the VCC high to the timer, making it flash. Now the flashing frequency or interval will depend on C1, which is 1 microfarad, R1, which is 1 kilo ohm, and R2, which is 85 kilo ohm. Those values will give me approximately 0.33 second intervals. So the circuit is very simple, but it works for all intents and purposes. Very well, so I'm gonna test right here real quick. So let me first restore this window. So I can demonstrate here what happens when we're activating the different buttons. I'm gonna start by using the cycle start, which will be the first run instruction right on the brain. If I press on the button, then you can see that it lights green and the button is illuminated. Of course, the jog is on all the time when it's active, right? So we can hold the feed right now with this button and then it blinks. And you can see the brain here in action that is flashing. Now if I proceed with the cycle, and then I can go ahead and turn it off or stop it completely. So you can see that turns on for a couple of seconds and then turns off. If I don't want to jog the machine, if I turn it off right here, that is not active, right? So if I want to increase the feed, it'll flash. If there's emergency condition, then I press on or push on the button and it'll start flashing. Of course, you cannot reset it until you restore the switch, neither from here or from here. All the other buttons are turned off because the ports will turn off. Now I can restore it, and now you can reset it, right? So once you reset it, then everything turns back on. So right now it's going to stop by itself at the end of the cycle, and you can see that it turns the red light on. As you can see, it is possible to make the buttons illuminate, providing that you write a brain for your applications or whatever function you're trying to implement on your machine. The good thing about running a brain is that it'll run in the background. All you gotta do is go to Configure, Save Settings, and then go to View, say Current Configuration, and the next time you start Mach 3, the brain will automatically be loaded into the program. I don't know if there's any better way to do this without using any external hardware. If you do, please let me know in the comments. Alright, this is gonna be all for this video. Thank you very much for watching, and I will see you next time.